Hello, my name is Grant Reeves and I am a sophomore at the University of California, San Diego, and I have recently begun my studying for the MCAT. I am using the Kaplan Complete 7-Book Subject Review for the 2019 and 2020 year, and this is Chapter 1 for the Physics and Math Review. So, Chapter 1 for the Physics and Math Review consists of 1.1 units, 1.2 vectors and scaling, 1.3 displacement and velocity, 1.4 forces and acceleration, 1.5 Newton's laws, 1.6 motion with constant acceleration, 1.7 mechanical equilibrium, and then a concept review. So 1.1 units. First learning goal is to recall the fundamental measurements and their units. So the fundamental measurements are length, mass, time, current, amount of substance, temperature, and lumos intensity. So length in an SI unit, it is meters. These are all SI units. It is meters, mass, kilograms, time, seconds. Current is amperes or coulombs per second, although the SI unit is amperes, which is an A. Amount of substance is moles, temperature is Kelvin, and lumos intensity is candela. So, order a given set of units that measures the same type of quantity from smallest to largest. So the example that is given here, it's angstroms, centimeters, inches, feet, and miles, and they go in that order. An angstrom is 10 to the negative 10th meters, or 1 times 10 to the negative 10th meters in scientific notation. So it's really tiny, and then it goes to centimeter, which is obviously much larger. 1.2 vectors and scalars. Explain the importance of order when performing vector calculations. So when you are making calculations, adding vectors together, it doesn't make a difference in the order. It will give you the same vector if you are visualizing it using the tip to tail method, right? So if you have a vector going this way, you have a vector going this way, you put them together. It doesn't matter if you put this vector, you have a vector going this way, you have a vector going this way, I guess, sorry. It doesn't matter if you put them like this, right? Your vector still goes here to here. Or if you put them like this, your vector still is going just horizontally like that. So calculate the scalar. So subtraction, it doesn't matter though. So whatever vector you are subtracting, right? So if this is vector A, so this is actually a good example. So if this is vector A and this is vector B, right? So tip to tail, you would normally put it this way. But if you are subtracting these vectors, subtracting B from A, vector B flips, right? Whichever vector you are subtracting flips the direction that it's going. So you have to make sure that you're subtracting. That order does matter when you're subtracting, but order does not matter when you're multiplying as well, because everything is communicative, it just multiplies together across. Generally, you will multiply a vector with another vector plus a trigonometric function, excuse me. Calculate a scalar or a vector as a product of two vectors using the right-hand rule when applicable. So the right-hand rule basically is just a visualization tool. I probably am not going to use it a whole lot because I'm fairly good at visual spatial learning and I can picture things in my head, but generally it just tells you if you have two vectors going this way and this way, then your palm is wherever your third vector will be pointing. So like this, palm goes out. Yes, I'm not really going to use it. Anyway, 1.3, displacement and velocity. Describe the relationship between average and instantaneous versions of velocity and speed. So speed is a scaling property, is a scalar, and scalar value, and velocity is a vector value, meaning Velocity has both direction and magnitude, and speed has only magnitude. Average velocity and average speed are their averages, so of course they are all scalars. Average, yes, so yeah. Velocity is vector quantity, speed is a scalar quantity. The instantaneous speed is the magnitude of the instantaneous velocity, and the average speed is always greater than the average velocity, because average speed takes into account the path traveled, where average velocity takes into account only the displacement. So average speed is always greater than or equal to average velocity. Distinguish between total distance and total displacement. Just did that. Total distance takes into account the path. Total displacement is just a straight line from point A to point B. Connect displacement and velocity with an equation. So velocity is equal to displacement, or change in x, delta x, change in the displacement of an object divided by delta t, change in time. There you go. So 1.4, forces and acceleration. Calculate a frictional force and predict its direction. So there are two types of different frictional forces. You have static frictional force, and you have kinetic frictional force, or dynamic, depending on who you're being taught by. So you can calculate both of those by taking your coefficient of static friction or your coefficient of kinetic friction and multiplying it by your normal force, obviously, respectively. And the direction and the frictional force direction is always opposite the motion and or force being applied. Okay. Describe the relationship between force, velocity, and acceleration. So force, velocity, and acceleration are all properties that can be applied onto an object, basically. So force are applied on or intrinsic to an object. So force is what will produce acceleration, and velocity is a characteristic that pertains to a certain object. So if all forces are equal, then your velocity will remain constant. If you have an increase in net force going in a certain direction, you will accelerate going in that direction. We'll touch on that more once we get to Newton's laws. Identify common forces, including frictional and gravitational forces. Yeah, easy. I mean, frictional force, kind of already touched on that. Frictional force always pushes the opposite direction than the motion or force is pushing, and gravitational force is obviously what pulls any object together. The equation for force of gravity is the universal gravitational constant, which is 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. That's represented by G times mass 1 times mass 2 divided by the radius squared. And for the final point in 1.4, explain the concept of normal force and how they impact a system. So normal force is just the force of an object pressing against another object. So if you are standing on the ground, the thing that is keeping you from falling through the ground is the normal force pressing on your feet. Section 1.5 describe Newton's 3 laws of motion. So Newton's first law of motion is an object at rest tends to stay at rest, an object in motion tends to stay in motion, basically saying that unless an object is acted upon by an outside force, it will continue to do what it's doing. That's why if you get into a spaceship and then you accelerate up to really, really fast speed, you will continue at that really, really fast speed because in space there's no friction to slow you down. So there are no outside forces continuing to act on you as you're hurtling through space, but you continue at that same speed because there's no forces slowing you down either. Newton's second law is force equals mass times acceleration. So that basically means that you can calculate how much force something used based upon, or how much force is being exerted on something based upon how much it's accelerating and how much mass it has. You can also obviously swap that around to solve for any of the other variables. An object of mass m will accelerate when the vector sum of the forces results in some non-zero resultant force vector. Basically saying that when the net force equals something, an object will accelerate. So Newton's third law, every action has an equal and opposite reaction. So for every gravitational force that's pushing you down onto the ground, the normal force is pushing back up. Right. So if I place this big jug of water right here, and I push on this jug of water, the jug of water is pushing back on me just as hard as I'm pushing on it, in order so that my finger doesn't go pushing through it. All right. Yes, so that's Newton's three laws. So 1.6, motion with constant acceleration. Identify which forces are active during different types of motion, including free fall and projectile motion. So free fall refers to when an object is mid fall, which means that the gravitational force, it means that it's no longer accelerating, which means that the acceleration presented by gravity is no longer strong enough to overcome the resistance from air pressing on something. So say if you're skydiving, as you're falling faster and faster and faster and faster and faster, you are encountering more air molecules pushing on you harder and harder and harder. And once you've reached a certain level where those air molecules are pushing on you hard enough, you are in free fall, meaning you're not accelerating anymore. And projectile motion, so say you have a cannon and you shoot your cannonball, right? So it's going to go in an arc. And for purposes of the MCAT, you are always going to assume that air resistance is not a factor. And so your motion in the x direction is going to remain constant with time, and your motion in the y direction is only going to be affected by the acceleration of gravity. So say that you, and there's multiple equations that they provide in order to calculate these different things. Yeah, so predict the angle of launch necessary to maximize horizontal and vertical distance. So to maximize horizontal distance, you're going to go for 45 degrees. Maximize vertical distance, you're going 90 degrees. Recall the equation used to calculate centripetal acceleration. Centripetal acceleration, I believe, is going to be mass times velocity squared divided by radius squared. Got it. Yeah, centripetal acceleration is, centripetal force, mass times velocity squared divided by radius, not squared, divided by radius. Okay. 1.7, mechanical equilibrium. Wait, I believe there was one more on here, actually, sorry. No, it wasn't, we're good. 1.7, identify whether an object is in equilibrium. Calculate torque within a system. So identify whether an object is in equilibrium. So if the net force in a system or on an object is not equal to 0, that means the object is not in equilibrium. So therefore, if the net force on an object is 0, the object is in equilibrium. Calculate torque within a system. So how you're going to calculate torque, there's a whole lot here. That's a tough one. Might want to look that one harder. And yeah, then you got your concept review. So torque, big one. Look at that. That's physics stuff. Anyway, thank you. Goodbye.